In Unix-based computer operating systems, Init is the first process started during booting of the computer system. Init is a daemon process that continues running until the system is shut down. It is the direct or indirect ancestor of all other processes and automatically adopts all orphaned processes. Init is started by the kernel using a hard-coded file name. A kernel panic will occur if the kernel is unable to start it. Init is typically assigned process identifier 1. In Unix systems such as System 3 and System V, the design of Init has diverged from the functionality provided by the Init in Research Unix and its BSD derivatives. The usage in most Linux distributions employing a traditional Init rather than a recent variant such as Systemd is somewhat compatible with System V, while some distributions such as Slackware use BSD-style startup scripts, and others such as Gentoo have their own customized versions. Several replacement Init implementations have been created, attempting to address design limitations in the standard versions. These include Launched, the service management facility, Systemd and Upstart. As of March 2015, Systemd has been adopted by major Linux distributions although it remains controversial. Research Unix style BSD-style. Research Unix Init ran the initialization shell script located in RC, then launched Getty on terminals under the control of TTYS. There are no Rune levels. The RC file determines what programs are run by Init. The advantage of this system is that it is simple and easy to edit manually. However, new software added to the system may require changes to existing files that risk producing an unbootable system. BSD Init was, prior to $4.3 Bahamian, the same as Research Unix's Init. In $4.3 Bahamian, it added support for running a windowing system such as X on graphical terminals under the control of TTYS. To remove the requirement to edit RC, BSD variants have long supported a site-specific RC local file that is run in a subshell near the end of the boot sequence. A fully modular system was introduced with NetBSD 1.5 and ported to FreeBSD 5.0 and successors. This system executes scripts in the RCD directory. Unlike System V's script ordering, which is derived from the file name of each script, this system uses explicit dependency tags placed within each script. The order in which scripts are executed is determined by the recorder script based on the requirements stated in these tags. Vstyle, when compared to its predecessors, AT&T's Unix System 3 introduced a new style of system startup configuration, which survived into Unix System V and is therefore called the Vstyle Init. At any moment, a running System V is in one of the predetermined number of states, called Rune Levels. At least one Rune level is the normal operating state of the system. Typically, other Rune levels represent single-user mode, system shutdown, and various other states. Switching from one Rune level to another causes a per Rune level set of scripts to be run, which typically mount file systems, start or stop daemons, start or stop the X window system, shut down the machine, etc. Rune levels equals. The Rune levels in System V describe certain states of a machine, characterized by the processes and daemons running in each of them. In general, there are 8 Rune levels, out of which 3 Rune levels are considered standard as they are essential to the operation of a system: 0. Halt, 1. Single user mode, 6. Reboot. Aside from these standard ones, Unix and Unix-like systems treat Rune levels somewhat differently. The common denominator, the init file, defines what each configured Rune level does in a given system. Default Rune levels equals, on Linux distributions defaulting to Rune level 5 in the table on the right, Rune level 5 invokes a multi-user graphical environment running the X window system, usually with a display manager like GDM or KDM. However, the Solaris operating system typically reserves Rune level 5 to shut down and automatically power off the machine. On most systems, all users can check the current Rune level with either the Rune level or who a command. The root typically changes the current Rune level by running the init or init commands. The init file sets the default Rune level with the init default entry. On Unix systems, changing the Rune level is achieved by starting only the missing services. For example, changing a system from Rune level 3 to 4 might only start the local X server. Going back to Rune level 3, it would be stopped again. Replacements for Init. Traditionally, one of the major drawbacks of Init is that it starts tasks serially, waiting for each to finish loading before moving on to the next. When startup processes end up I/O blocked, this can result in long delays during boot. Various efforts have been made to replace the traditional Init daemons to address this and other design problems, including boot scripts in Gobo Linux, BusyBox Init, suited embedded operating systems, employed by OpenWrt before it was replaced with PROCD, daemons, a modification of the Init start process by KHEL-OS, where daemons are started only when the DE started, Init, a full replacement of Init designed to start processes asynchronously, but with the potential of doing it without shell scripts, DMD, a GNU project for a service manager acting as a dependency-based Init replacement, Epoch, a single-threaded Linux Init system focused on simplicity and service management, INITNG, a full replacement of Init designed to start processes asynchronously, launched, a replacement for Init introduced in Mac OS X v10.4, Muda, an Init replacement written in Python and designed to start process asynchronously in use by the Parduse Linux distribution, Nosh, a suite of system-level utilities for initializing and running a BSD or Linux system, for managing daemons, terminals and logging, OpenRC, a process spawner that utilizes system-provided Init, while providing process isolation, parallelized startup, and service dependency. Used by Gentoo and its derivatives, Runet, a cross-platform full replacement for Init with parallel starting of services, S6, another cross-platform full replacement for Init, similar to Runet, Service Management Facility, a complete replacement redesign of Init from the ground up in Solaris starting with Solaris 10, but launched as the only service by the original system Vstyle Init, Systemed, a full replacement for Init in Linux with concurrent starting of services and other features, used by influential Linux distributions, System Starter, a process spawner started by the BSD-style Init in OS X prior to Mac OS X v10.4, Upstart, a full replacement of Init designed to start processes asynchronously initiated by Ubuntu. See also: Operating System Service Management. References. External links: FreeBSD Init man page, paper summarizing Unix Init schemes, SMF and milestones in Solaris 10.